Hello and welcome to another lesson in our operating systems course, Beginning Linux. In this lesson, we'll discuss disk partitions and formatting. So overview for this lesson, we'll cover partitions, how to format them, and then how to mount and unmount those partitions into our broader file system. So for our introduction, a little reminder of what a file system is. It's just a system that organizes and stores files on a storage hardware. So that could be a hard drive or SSD. So essentially it's organizing the directories. Remember, that's another name for folders and the files that they contain. So it turns out before you can actually store files on any storage hardware, be it a hard drive, SSD, you have to go through a specific process to actually prepare that hardware for storage. So when you first manufacture, it's actually not ready for you to store files in it. So those hard drives or SSDs are just empty space when you first get your hands on them, when they're first manufactured them. So you actually need to structure those hard drives, those SSDs, in order to store files. So the first step is partitioning them. So just like you divide a bookshelf into different sections, you do the same with storage hardware. You have to partition it, you have to section it out, depending on what kind of files you're going to be storing in each section. So just like I said, there's different sections. Well, each section might have a different format. So partitions have specific formats depending on what type of file system you want to store there. So just like your bookshelf, right, you might put your books in one section, your magazines, or maybe you put a certain category of books, right, in one section. The same goes with your storage hardware. You actually have to tell the system what format they can expect, what kind of files can they expect to store there. All right, so disk partitions. What are disk partitions? Well, they're separate. What they do is they separate storage devices into multiple independent storage areas. So from the perspective of the system, each partition appears like a separate disk. So even though you have one hard drive, right, as soon as you partition it, the system's going to treat that as an independent drive. Some of these disks, some of these partitions, I should say, can even have their own file systems. So you can have entirely different operating systems running on each disk, as we'll see is one of the main purposes of partitions. So Linux supports several partition types, and each has a specific role. So it does a specific thing in the system. So there are three types of partitions. There's a primary partition. So that's a main partition of the hard drive. Now, if you want to do extra partitions, right, sometimes a disk will have a limit on how many partitions you can do. These other two partition types are kind of a little hack in order to continue splitting up the hard drive. So you have extended partitions, which essentially hold smaller logical partitions. So that can help you extend the limit on certain hard drives. We'll see that as we go through some of these slides. All partitions, they're tracked on the partition table. So what is the partition table? It's just a map of all the partitions on a storage device. Helps the system keep track of where each partition is, where it ends, and what it's used for. So it helps the operating system know where to find your data. And if you're running multiple operating systems, so it is possible to have Linux in one partition, Windows in another, Mac OS in the third partition. It's really, really important that there is a partition table so that the system knows where everything's at. Without it, it'd be a big mess of data, and your computer wouldn't know where those operating systems at, where those files at, or other type of data is stored. So there are two types of partition tables. There's the master boot record. So like I said, some partitions have limited number of partitions you can make. The MBR type has a max of 4. So that's where you can do extended partitions and logical partitions. Those types really just exist so you can extend past that limit. It's like a little hack. Then there's a more modern GPT or GUID partition table that has a really high maximum, so you probably don't really need to do many extended or some of the logical partitions, right, that you have to do with the MBR, unless you do, in some cases, right, hit that limit. So primary partition, it can hold a whole operating system, system files, or other important data. So think of this as one of the main rooms in your hard drive, one of the main sections on your bookshelf. So your Linux operating system is typically installed on a primary partition. So your actual VM, right, is running Linux, so that Linux OS is stored in a primary partition. Now you can have multiple primary partitions, right? So you can extend, you can add rooms essentially to your hard drive, and you can add different types of OS. So you can have two Linux distributions, right? You can run Ubuntu on one or Kali on the other one. You can have totally different types of operating systems, maybe Linux on one, Windows on another, or even Mac OS on a different one. There is a caveat, right? As long as the hardware is compatible with the OS, for example, in Mac OS, not all hardware can actually store Mac operating systems. Apple, they have that ecosystem. It goes the same with their hardware. So yeah, that's actually one of the main purposes of partitions. A little clue for this week's quiz, perhaps, or this week's lab, if applicable. These types of partitions, their main purpose, one of the main purposes at least, is to run multiple operating systems. It's very, very cool. So you can have one machine and run two different types of operating systems. Then there's extended partitions. So it's a special type of partition that acts as a container for other partitions. So like I said, this just helps you bypass the limit. For example, on the MBR disk, you can only have four, so you can extend it using the extended partitions. You can only have one extended partition per disk. And it doesn't actually store data. It's a container for smaller logical partitions. So think of it as adding extra shelves on your bookshelf. But those shelves, right, don't actually hold the books themselves. You have to add these like smaller specialized shelves. Maybe not the best metaphor, right? But bear with me on that one. Just know extended partitions, they just allow you to have extra partitions. And the ones that fit inside those extended partitions are called logical partitions. So logical partitions are additional storage sections inside an extended partition. So they just allow you to divide extended partitions into multiple usable areas on your disk. So again, for the MBR that has a limit of four partitions, the extended partitions help you hack, right, that limit, bypass that limit. So yeah, if you want to run even more OSs, right, you can use extended and logical partitions to do that. So next up is the disk partition commands. So we're going to go over the commands. At the demo in the end is where we'll actually use these commands. So first is the fdisk command, which is short for fixed disk. This is what you use to create, delete, resize, view partitions. So it essentially opens up your disk for partitioning. The syntax, because we're editing the system files, it's going to be sudo in front, and then fdisk, and then whatever flags you want, followed by the path of that disk. So we're going to be doing a lot of these partitions on the dev folder, which the dev folder holds those important disk drives. So for example, you might see SDA, which is your main disk. We're going to be adding in the demo a virtual disk, which is the same as like plugging a USB or plugging in an additional SSD. That's that virtual disk is going to virtualize, right? It's going to emulate that kind of process of plugging in extra disks to your system. So you'll see SDB as well. But yeah, these examples are just examples of running a partition command. So you want to partition the disk SDB, you could do sudo fdisk/dev/sdb. We have sudo fdisk-l, which we'll cover in a sec, and then we have the -s flag, which we'll also cover. So if you want to see all the you want to list the partition tables for all the disks, or for a specific disk, you could use the -l flag. Without an argument, it's just going to list all the tables. If you actually give it a specific disk path, so for example, the dev SDB disk, then it's going to give you the partition table only for that disk. Keep in mind, you can only give it one disk at a time. Fdisk does not handle multiple disks, as many other commands do, right? Where you can give it multiple file names or multiple directories. You can't do that with fdisk. And then we have the -s flag, which will just give you the size of each partition. In blocks, that's the unit they'll give it to you in. So useful if you just want to see, right, the size of each partition, see how much of your main disk it's taking. So my most useful command would probably be fdisk-l because it provides all the partition tables. Of course, fdisk on its own is also super important, right? Because that's really what makes partitioning possible. Next we have the df command, which is disk free. That's going to create, delete, resize, and help you view partitions. So df, your options, right, your flags, and then the file or directory name. So we have a few commands here. We're going to cover them in the next slide. So really, my favorite one is the df-h. We'll see what that does. So df-h actually displays the disk usage for all mounted file systems. I like this one because it helps you verify which partitions have been mounted. Now, we haven't covered mounting yet, but we'll cover that in the next sections. This is just a great way to verify that you did mount one of those partitions. Another useful flag is -t. That's going to give you the file system type for all mounted file systems. So that's when you don't provide the argument, right? It's going to do it for all the disks, all the partitions. When you do provide a file directory, well, then you're pointing it at a specific partition. Next up is formatting file systems. So once you split up your bookshelf, you actually need to tell the system, right? What type of books, magazines, right? What type of things are you going to store on the shelf? Well, that's what you have to do for the disk, right? You have to tell the system, hey, what type of files, what type of data are you going to be storing in that partition? Because if it doesn't know how, it might not organize it in the right way. You can't expect the system to know whether it's going to be an operating system, whether it's going to be just regular old files, right? Maybe like on a USB drive. I know we don't really use those these days. But yeah, depending on what you're storing, depending on the hardware, um, you might have different partition types, partition formats. So the storage device can be a hard drive or a USB. Remember that file system controls how data is organized. So what does formatting do? It essentially clears all the data on the drive and sets up a structure for those files, so a certain way to organize them. Again, depending on what you're storing, it's going to have a different structure, a different way of organizing those files. An OS will organize things very differently than a regular old USB drive or SD card might do. SD cards, right? Memory hardware that we use for smaller devices such as cameras, um, video cameras as well. So why does formatting matter? It's required on brand new drives, so you do need to format those coming out of the factory. It's also useful for corrupted disks. Sometimes the hard drives get messed up. And in order to fix them, you can reformat them. So different formats handle different needs. So let's take a look at the different types. So when you're working with the operating systems, we have a type for each operating system. ext4 is for Linux. So your VM does have a partition for ext4 or in the ext4 format so that we can run the Linux operating system. We have NTFS for Windows. So that's essentially the type, the format, right? The structure for the Windows operating system. We have HFS or APFS for Mac OS. For USBs, we have the FAT32 or EXFAT format types. And then each type is also going to have different file size and storage needs. So, for example, the FAT32 can't store files over 4 gigabytes, typical of a lot of USB drives. The NTFS, though, and the EXFAT and the ext4, right, which is for Linux, that last one, can handle much bigger files. Some other ones that handle much bigger files. So if you're running a server computer, there's the XFS. If you need extra features, there's the NTFS and ext4, which have file permissions and security. The FAT or the FAT32, right, for example, doesn't have any security, which is typical of USB drives. So partitioning and formatting, like why do we need both of them together? Why are we talking about them together? Well, formatting tells a partition how to store and organize the files. So you must format a partition before using it. You have to prepare that partition for use. So partitions are where to store the data. Formats tell the system how to store it. So you do need both to organize and access the files properly. So you can have one partition formatted as ext4 for Linux. And again, remember, one of the big purposes of partitions is that you can run multiple operating systems. So you can have another partition formatted for Windows. If you don't format it, then it's not going to know what to expect. It's not going to know if it's going to be a Linux OS, a Windows OS, maybe not an OS at all, right? So this is why partitioning and formatting is really useful for dual or multi-booting, which means you can switch between different operating systems on a single computer, on a single machine. So some of the formatting commands, there's really just one main one. It's the mkfs command, which is an acronym for make file system. So all it does is partition a drive to a particular type. So it's going to be sudo again. You can use the flag to indicate the type. There's also a different format for this command where instead of using the flag, you could use a period and then put the type. So for example, if you're formatting to ext4, these commands actually do the exact same thing, just slightly different formats. We'll explore that in the next slide. So yeah, the dash T flag, you do need it so that you can tell the system what kind of file system format it's going to use for that partition. And of course, right, the argument, can't forget, the argument's the location of that partition, where is it at? The second format is called an alias. So you can actually set these up on your own. You can make custom aliases for your commands. So commands that you use a lot, you can actually customize the format. Some commands already have custom formats, such as the mkfs command. So essentially, it's just a different way to type it. It might save you like, half a second. Us programmers, we like to create as many shortcuts as we can. We like to save time. But both formats do this exact same thing. Just keep in mind that the alias or the shortcut format doesn't always work for every single partition format, every single formatting type. So definitely the dash T flag, you could use that one because it's a little bit more flexible. So different formats, we have ext4, again, that's for Linux file system, example command there at the end using the shortcut format. We have vfat, which is for flash drives, USB drives, SD cards. We have the dash T flag format there. And then we have some of the other ones, right, for Windows. For servers, we have XFS. An advanced Linux file system type, we have the BTRFS, which has extra features such as snapshots and compression. Yep, check out those example commands. And notice again, we're in that dev folder. Dev folder is where we keep those disk files, those important partition files. So how do we actually make these partitions available, right? So we did the step of splitting it up, of telling the system what type. Now we actually need to, hang up that bookshelf or, fully construct it, open it up, right? So that people can actually access those books. So this is called mounting. So that's a process of connecting a storage device or partition to your file system. So it makes the files on that partition visible and usable to your system. So it's just that last extra step to plug in your system to open it up to your computer so that it can actually access that operating system or those files, whatever you're storing in that partition. So wherever you actually put that partition in your directories, that's called the mount point. So you can put it anywhere. For the most part, we do have a folder for that in the root of the Linux directories. That's the MNT directory. So if you do cd/mnt, it'll take you to that folder. And then you can create extra folders there. Say you want to do USB mounts, you could create a USB one. If you want to do CD-ROM, right, kind of a legacy storage system. We don't really use CDs anymore. But yeah, that's another example, folder you can create to organize those mount points. But wherever you mount that partition, it's just called the mount point. You can put it anywhere you want. You could put it in your home directory if you want to. But yeah, for the most part, we do use certain folders, such as the mount folder. So without mounting, the system can't read or write the files on a device or partition. So this is why mounting is so important. So you can create mount points anywhere in the file system as long as you have the permissions, of course, right? So that's why we use sudo a lot when we're doing partitioning, formatting, and mounting. Well, sometimes you also need to unmount a system, right? Maybe you only need to temporarily access those files, especially if they're sensitive files. There's other reasons as well that we'll cover here. So one of the reasons you might unmount something is to prevent data corruption when you actually remove that hardware. So type of hardware that you will actually remove is like a USB drive. You don't always have it plugged into your computer. You might carry it right onto another computer. Unmounting is actually an important process to make sure that those files don't get corrupted. So let's say you dragged thousands of files into that USB. You unplugged it, a little bit too early. That could corrupt the files in there. So unmounting, when you unmount it first, it's going to make sure that you don't mess things up. So this is similar to that eject operation on Windows, for those of you that are familiar. So on Windows, there's an eject operation and eject feature for those USB drives that you're supposed to do before you unplug it. For the most part, these operations are very quick. You're probably not doing too many. Some of these also have like default settings to avoid corruption in the data. Back then, it was a little bit more common for those corruptions because of the speed, right, of read-write operations. But yeah, unmounting is just a safe way to, unplug that file system from your broader system, especially for hardware, right, that you actually remove from the rest of the hardware, from the rest of your computer. So now that we've learned how to mount file system, let's tie it all together with our previous topics. So remember, a partition is a section of the disk prepared to hold the data. Formatting a partition organizes how the data is stored on that partition, and then mounting is actually what connects or opens up that partition so that the rest of your operating system can use it. So just a couple more commands specifically related to mounting. We have the mount command, of course. This one's pretty straightforward. It's to mount, you know, a file system to a particular mount point. So it's sudo, of course, because we're making changes to the system files. Mount, whatever flags you want. And then the actual partition that you're mounting. So for example, it might be dev stb, as is the example in the video. And then we have mount point, right? Where do you want to mount it? Well, remember, a great place to mount it is in the mount folder. That's kind of just one of the conventions in Linux. So some of the flags, we have the -t. This is just to confirm the type of file system that you're going to be mounting. It's kind of redundant, right? Because when you format it, you're already telling the system what the type is, but it's just good in certain cases. If you're doing scripting, that's always a great way to double check, to double confirm, right, that you're giving it the right file type that you expect. If you want to mount a file system as read-only, right, so that you can only read it and not make changes to it, you can use the -r flag. By default, it's always set to read-write. It's going to give you both permissions. The -w flag will do that explicitly. We also have the unmount command, which is the umount. So umount, right, a little bit shorter than unmount. Same idea. You give it the command with sudo in front and then a mount point. You don't need to actually specify, right, the partition, right, because you can just give it the mount point, or you could give it the partition location. So there's a slight difference between giving it the argument of mount point versus the argument of partition. When you give it the mount point, you're telling it to detach whatever partition is mounted to that directory. When you just give it the partition name as the argument, it's going to look for all the places that it's mounted. So potentially it'll target more places when you give it the partition name. So slight difference. It does the same thing, but it'll have a different area of coverage essentially. So in the demo, we'll cover partitioning, formatting, and mounting, which will be essential for this week's lab.